So question number three, it's about a bank uh, road with angle 40 degree, and then there's a round track. This would be the center of the circle. So the race car is doing a circular motion along this horizontal plane with the center right here. So the radius equals 85 meter, and the coefficient of static friction between the track and the race car is 0.2. Now this coefficient for the static friction is very small, so it's not realistic. In fact, this should be big. So we just make up this question, to practice. Now, question asking what is the minimum speed the race car has to have to stay on track? Okay, this is very important, the information about speed. If it's question asking for maximum speed, and then it's a different story. So now you can try if you let the car, race car stay there, and then you can calculate what's the sliding force, which is the component of Fg down the slope. So that would be greater than the friction can hold on. So then the car has to move to have to undergo a circular motion so that the inertia will try to help the car stay on the track. And in that case, anyway, because it's the minimum speed, so at the minimum speed, so we must have the friction is helping us to prevent the car from sliding down. So that's the key to determine the direction of friction is supposed to be up the slope, not down the slope. And then we can have a close look at all the forces. Friction here, normal force, as normal in this direction, perpendicular to the slope. And then we have a gravity pointing down. So as long as a circular motion problem, so we must have a acceleration pointing to the centripetal, right? And then the other direction, which is perpendicular to the centripetal direction, here must be without any acceleration. So that's why we choose this centripetal as one of the direction, and then the perpendicular direction at the other one. So, and once you decide that, you have to resolve all the forces which is not on this direction into the components. So the Fn normal force we resolve into Fnx and Fny. The friction here we resolve into Ffx and Ffy, so it's pretty small. Hope you can see yourself. And once you resolve all the forces into the components, you can calculate all of them. So you just need some geometry, so you can figure out the angle here is 40 degree equal to this angle. So then just use the trigonometry to find out all the components in terms of the Fn. And in here, the friction must equal the mu multiply the Fn. Because at the minimum, so the FF must equal to the maximum possible friction. And then we just gonna use all these components we listed here to make up our equation. So along the centripetal direction, we should have the net force equals ma. So net force is Fn x, which is Fn sine 40 minus mu Fn cos 40, that's Ffx, which you can find it here. So because they're in different directions, so you have to subtract this one, subtract that one. So this one has to be bigger so that we have net centripetal force equals to mv squared over r. So always you have this equation in circular motion problem. And then on the vertical direction, the two forces both going up, the Fny, Ffy, added together, it should be balanced with gravity. Okay, now after you set up these two equations, then it's your math skill to help you to figure this out. So one way, of course, you can figure out the Fn from the second equation. You can actually find out in terms of mg. Now you don't know the m, so you can't actually find out how much Fn is. But then if you plug in, so the mass will be cancelled, right? So if you like that way, go ahead. But I always like to divide by the two equations. And you can see if you factor the Fn out, so the Fn, when you divide, cancel it out, M cancel it out. So then if you isolate V, and you should be able to get this. Okay, and then plugging everything, you get this answer.